Hey everyone, welcome back. Salman here, and this is episode 3 of our Snowflake Enterprise Platform from Scratch series. I want to start with a number. In my time doing Snowflake administration, I have seen teams waste tons of thousands of dollars per year on idle warehouse compute. Not because they didn't care, not because they weren't technically competent, because they didn't understand three things. What are those? How to size a warehouse correctly. Okay. First is how to size a warehouse correctly. Second one is how to auto suspend actual work. And this one is the trap. The title is about when multi cluster warehouse help versus when they silently double your bill without fixing anything. Today, we fix all three and we do it by building the real warehouse architecture for Northwind, our fictional company. By the end of this episode, Northwind will have 4 domain specific warehouses, each tuned for a different workload type, and you will have a sizing decision framework you can actually apply to any Snowflake environment tomorrow. High demo ratio today, so let's get into it. Uh, this theory, I also at one point of time I thought ki this theory is too much, but we need to understand the concept. Okay, before we get into episode 3, I would like to get into a quick 60-second recap. After episode 1 and 2, Northwind has a Snowflake Enterprise account on AWS, a framework based architecture, a decision documented, single account with environment prefix databases, okay, and 9 databases across 3 domain and 3 environments. Okay, so let me draw a diagram so that you all follow along with me. Let me quickly switch to this notepad. What we have one Snowflake account. And within this account, we have 3 environments: prod, UAT, there. Okay. And then we have 9 databases across 3 domain. Okay. So 333, like marketing database, Okay. So the sales, marketing, and finance kind of databases we do have. Now, what we do not have is a sensible warehouse strategy. So we have one single account, and then uh, we do have three environments, and we have nine database. We have created it. Okay, in the second episode. Right now, Northwind has one warehouse for episode one that we have created, like ETL warehouse small. That warehouse is being used for ETL jobs, analyst queries, and anything else anyone wants to run. One size, one team's worth of compute. Everyone's sharing it. The problem with that, ETL jobs and dashboard queries have completely different compute profile because they're going to take different time. A DBT transform that runs for 20 minutes and a Tableau dashboard refreshes that needs sub 5 seconds response time should not be competing for the same warehouse. And from a cost attribution standpoint, if everything runs through one warehouse, you have no idea which team is spending what. Okay. Today we fix that. We are going to retire that ETL warehouse small, which we have created in the episode one, and it gets replaced by four domain specific warehouses, each sized and configured for the workload that owns it. So I think drawing these diagrams, which will help you to understand where we are, but it is going to take much time. Like I wanted to make short episodes of like 15 to 20 minutes so that you get enough time to go through it. Okay. Before we get into sizing, let me make sure this foundational model is locked in. And because if you have this wrong, everything else about warehouse configurations make less sense. So as we know, Snowflake separates storage from compute completely. Your data, all nine of Northwind's databases, every table in every schema lives in Snowflake's shared storage layer. That storage is always there. It doesn't go away when warehouse are suspended. It is billed per terabyte per month flat rate for storage. Okay. Warehouses are the compute layer. They are ephemeral. You spin one up, queries run, it suspends. The data it was querying is still in the storage layer. The warehouse is gone. No credits consumed while it is suspended. So it is as simple as that. Okay. Warehouse for virtual warehouse we're going to use it for all the DML operations that we're going to perform in our account. So it is as simple as that. And it is warehouse is getting built per second kind of model. Okay. And the storage is built per month, like per terabyte per month flat rate according to your uh, version of Snowflake that you have selected. Let me go back to next size. So there isn't any kind of standard rule for sizing, but every Snowflake size doubles the number of compute nodes. Excess, that is the starting node, starting size, is one node. We are going to get one node. What does that mean? One node is like we are going to get one compute, one EC2 instance in the AWS. If you choose S, we are going to get two nodes, M4, L8. It is like going to double it every time up to 6XL. And critically, every size doubling doubles the credit consumption rate because you're taking the compute power. So the credits also will get increased. Excess burn 1 credit per hour. So S burn 2 credits, M burns 4, L8, and vice versa. What people get wrong is assuming bigger size automatically means faster. Sometimes it does, but the relationship is not linear for most workload. Okay. So let's say if there is any network bottleneck and I'm selecting the warehouse size as in 4XL, that doesn't make sense because the problem is not with the compute. The problem is something else, network bottleneck. And my suggestion is always go slow, go small, and we can resize it later based on the query profiles, whatever the queries that are running. So that is it for this slide. Auto suspend setting it for workload, not for account. Okay, so now this is the slide I wish if someone had shown me earlier in my career. Okay, let me show you the warehouse life cycle so you can see exactly where your money goes. Hmm? A warehouse has four states: suspended, warehouse is suspended, zero cost. Provisioning means warehouse is waking up, takes roughly 1 to 2 seconds, no cost. Okay, running means actively executing a query, credits being consumed, and this is the expensive state nobody talks about. Idle, idle countdown. The warehouse has finished executing but hasn't hit its auto suspend threshold yet. It is still running. It is still consuming credits. It is doing nothing. Okay. The idle countdown state is the entire reason auto suspend exists. Okay. So auto suspend controls how long a warehouse stays in that red zone after its last query finishes. If it is set to 600 seconds, you are paying for 10 minutes of nothing every time a query completes. Multiply that by 20 analysts running dashboard throughout the day. So this is how you are going to waste your credits for the ideal warehouse states. Okay, that we are going to optimize it in the FinOps series. Oh, no issues. And before we go live, a quick refreshes on all four parameters we set explicitly on every warehouse in this series. We covered this in episode 1, but I want them locked in again. Now that we understand the sizing and suspend reasoning behind each one, warehouse size to the workload. First is warehouse size. Okay. Second is auto suspend, auto resume, and initially suspended is always true. Okay. Every warehouse we create today will have all four set, no exceptions. Okay. So let me see. Okay. So here is the warehouse architecture we are building for Northwind. Four warehouses total. Okay. Three for business domain, one for platform administrations. So first one is ETL warehouse medium. Okay. Owned by data engineers. So let me switch to my Snowflake account. Okay. So first is like the ETL we are going to warehouse we are going to create for data engineering team. We are keeping the size as medium because our copy into jobs and DBT transformations will be operating on tables in the tens of millions of rows range. Memory headroom matters here. If I start seeing spill to disk in the query profile, I will upsize to large. Okay. Auto suspend is 60 seconds because ETL runs in the scheduled burst, not continuously. Okay. So it is same like create warehouse if not exist ATL this warehouse size we kept it as medium, auto suspend 60, auto resume true, initially suspended true as we have decided, and comment. Oh, naming conventions. Let me create it. Okay, warehouse is created. The second is we are going to create it for analyst team. Okay, and Tableau BI team. Okay, same like BI warehouse small. We are keeping the warehouse size small because individual BI queries on a well modeled data mart should be fast and small. small size. And the result cache means and the result cache means repeat queries often cause zero compute. Okay. And auto suspend is 120 seconds for analyze session continuity. This is the warehouse that will eventually get multi-clustered enabled, but not today. And I will explain what exactly in a few minutes. Okay, what multi-cluster means like. Okay, but initially suspended is true, and minimum cluster count is one, maximum cluster count is three. So what multi-cluster does is like if multiple BI users they submit the queries and one node is not enough, so it will automatically spin up three nodes. Okay, let me create that. This warehouse is also created. Close this query history. Now we are creating the third warehouse, which is owned by data science and eventually by the Cortex team. Uh, Auto suspend we are keeping it at 300 for iterative sessions support, because for the ML engineers they will run their algorithms, their codes, which will have iterative sessions. So we're keeping it as in 300 seconds. Okay, let me run that. And last one is for admin. Okay, we're keeping it as X small because the platform team, meaning us, uh, admin queries like show commands, account usage queries. So I'm keeping auto suspend as 60 as well. Okay. Now we have four warehouses created as we promised, and I wanted to retire that warehouse that we created for the first episodes. Let me uncomment this. Let me show the data warehouses. It will show four warehouses that we have created. Admin, BI, data science, and ETL. All of them are in the suspended states. Okay. So we have created our warehouses, and I wanted to cover more on the theoretical part of the warehouses because they are going to ask you a couple of questions with respect to warehouse. Okay, so let me uh, get into this warehouse screen. They will ask you what is the difference between Gen 1 and Gen 2. Okay, so this is basically the speed of the operations, the core they are introduced in the Gen 1 and Gen 2. The operations are pretty fast using Gen 2 warehouses. Okay, they have just upgraded the hardware. You can say it. This iterative is used by the ML teams. Okay, and this adaptive is like it will automatically scale up when it is required. So they'll ask you that, and they will ask you about the warehouse sizes and the nodes that will require. So the small trick is like access goes with 1 and you can double it every time you will go. Okay. And then they will ask you about the credits cost as well. Okay. In the advanced option, this auto resume, auto suspend, like if my warehouse is suspended, if somebody submitted query which is assigned to this warehouse, it will automatically resume. Auto suspend, like after few minutes of activity, few seconds of activity, it will going to inactive. Okay. If the warehouse is idle. In the multi-cluster warehouse, they will ask you like what is the minimum and maximum cluster and the scaling policy. So if I want to explain you about the standard and economy policies, these are like nothing but uh, in the standard. I think it will spin up the new cluster within 20 seconds of time, I think. And for economy, it will it will try to freeze the queries. It will try to freeze the core by waiting for up to 20 minutes, I think. I'm not sure about the timing, but I will check it and I'll let you know. Okay. So it will like quickly spin up the new cluster and it will wait for the queries to finish up and consume the same cluster. Okay. These are the difference. And this query acceleration is the new feature they introduced. It will give you more core and you can scale the factor from here. So these are the few interview questions they will ask you during the interviews. Okay. Let me stop the recording now.